Hello, everyone, and welcome back to another Fusion 360 live stream. I'm your host for today, Jason Lichtman, and today's topic is going to be latticing. In particular, how to design a lattice for 3D printing. We have a packed agenda, so I'm gonna just go and show you that agenda here for a second. Let's go to my screen and switch over to my PowerPoint. Perfect. So we're going to start off by talking a little bit about what is latticing, how and where to access latticing, like how to turn it on within Fusion 360. We're going to cover how to use latticing in quite a bit of detail, and then we'll talk a little bit about 3D printing in metal versus 3D printing in plastic, specifically for the latticing application. And then we're going to get into tips and tricks for achieving great results. That, in my opinion, is going to be probably your favorite part. But let's get into the good stuff. So, what is latticing itself? So, latticing is a way that you can create three-dimensional structures within your part. Typically, it's used for lightweighting, but there are plenty of applications where you do this just to make your part look really cool. Remember that consumer products are often purchased based on the initial reaction, your emotion when you see the product. So, being able to make your product look really cool can have quite a bit of value. But most cases, we're trying to lightweight our parts. So how do you actually do latticing, so to speak? There are plenty of softwares out there that do latticing, but they are more often than not quite expensive. What I love about Fusion 360 latticing is that you can get to it for a really low entry cost. So let's talk about how you get there. So first of all, latticing in Fusion 360 is available as a preview feature in the product design extension. So if you want to have access to latticing, you're going to need access to a commercial license of 60 plus the product design extension itself. And once you do, you can turn on the preview functionality and actually start getting started with it. I'll show you what that would look like. So let's go and share my screen again. I'll jump right into Fusion 360. And let's go into the top right corner. You're going to see you have a preferences option here. And in the preferences in the bottom left corner, you'll see a section for preview features. We're going to go over and just take a look at the extension features. And right here in design, you'll see one here for volumetric lattice. So even after you do have the product design extension, you are going to want to turn on this checkbox and hit the OK button to be able to access the volumetric latticing. So let's go and actually do that. Mine's already turned on, so I'll just go and hit OK. And once you do, you're going to find the latticing under the solid tab that's right over here on the top. And under modify, you're going to see volumetric lattice right over there. And so let's actually just go and get started. By the way, we're going to start off with a really basic cube just so that you get the idea of like what's happening inside here. And then we'll jump to a much more fun example in just a. So we turn on volumetric lattice. You pick the solid body. Let's go and confirm that we do have a solid body. We're going to start off with a 50 by 50 by 50 millimeter cube. And let's go and pick that body. And in just a few seconds, you're going to see the lattice structure show up. Now, in order to be able to do all of this, what Autodesk has created is what we're calling a volumetric kernel. So this is still a solid body, at least at first glance. But what's happening is that we're defining what's happening inside that solid body, and then we can use that to our advantage for a variety of different things. But this is how we're able to actually show you these structures and change these structures incredibly quickly without having some performance hits that you might expect. So let's go and take a look. For cell shapes, right now we only have three options: gyroid, cross, I'll show you what that one looks like, and then also Schwartz P. There are hopefully going to be more options in the near future, but right now these are the three cell shapes, as we call it, that are available. My favorite happens to be the gyroid, so we're going to go and use gyroid today. In terms of cell size, you can change that cell size to whatever you'd like. You input a number, so I'll just go and type in 5, for example, and it gets much smaller. Or of course, I could type in, let's say 20, and it's going to get much bigger. But if you want to have more fun with this, click the scale button right above it, and then now you'll have an arrow on the screen that you could actually drag to whatever number you want. Right? We try to make this a little bit more interactive, and this arrow is a great way to be able to have that interaction. So change this to whatever size you'd like. And again, this is the size of the cell. If you do want to rotate those cells, right, because right now it's lined up with X, Y, and Z, you can also go and choose this move or rotate button, and then you can actually slide the cell structure itself over so that a certain face of your part has more solidity or less solidity, or it lines up with something in a certain way. So you can actually just go and drag them, and then also you'll see that you can rotate this and make this a little bit more at an angle. You could do some pretty wild stuff with that as well. Now I'm going to undo those changes. We're going to just keep this pretty simple for now. But just know that you can, of course, manipulate this in a variety of different ways. The second thing that's important is what we're calling solidity. And the solidity is, well, let's actually just show you. I'm going to go and change that number from, let's say, 50 to, let's say, 80. And you're going to see that there's a lot more solid mass to this part. Just like in the setup, you can actually change this a little bit more interactive by just dragging this slider. So instead of the arrow being on the screen, like on the part, you have the slider here in this window. You can change this to a variety of different things. And I love the ability to do this because you never know what's really going to work for you or look best until you see it. You could actually just go and change that. But if you want to have real amounts of fun with this, change the distribution from uniform gradient along a path. Now for this, you are going to have a path. And you can create a two-dimensional sketch, or you can create a three-dimensional sketch to control this. I've already made a sketch, so let's go and show that. And this is a 3D sketch, but again, you can use a 2D or a 3D. I'll show you this from a variety of different views before I actually go and use it. So you can see it's going from one corner of this cube to the opposite corner of the cube. It's rotating a little bit in that direction. And if I look at this from the front, it's also moving in that, upwards into the top right corner as well. So this is very 3D, and this happens to be a spline, and I'm going to edit this in just a few minutes. But first, let's go and use it. So I pick the path, that'll be that sketch. And what it's now going to do is it's going to change the solidity based on that path. And by default, the options are going to be to start with a 0 solidity. And I'll admit, I changed this pretty much instantly to 10 or something a little higher. And then for the end of this path, it automatically sets this to 100. I usually change that to around 80, at least to start. And what you're going to see here that I think is really important is a gradual change of that solidity from one end of the path all the way to the other end of the path. And on one end, it's starting at a 10% solidity. And on the other end, based on these numbers, it's 80% solidity. And you can change this to whatever you want. And that to me really opens up the doors to be able to make some pretty wild lattice structures. Now keep in mind, by the way, that if I hit OK and I go to edit my sketch, I can actually edit my sketch and it's instantly going to change my lattice structure. So let's go and grab this particular node. And you can see that as I move my actual sketch, my lattice structure itself is completely manipulating right now, instant on the screen. And that to me is just absolutely mind-boggling. And remember that the reason that this is happening so fast is because of that volumetric kernel. So this is not a mesh at the moment. This is still a solid body, but because of that volumetric kernel, it's defining this as more than just the outer boundaries. You've probably seen in other videos, we call solid bodies boundary representational solids, or BREPs. And that's really because we're defining the object based on those boundaries. But what the volumetric kernel is doing is letting you define not just the boundaries, but what's happening inside it. And that's, of course, the lattice structure that we're playing with right now. So let's say for a moment that I'm happy with this, except for the fact that I need a flat face to be able to maybe print this. And by the way, in real life, you don't need a flat face. But what if you do want a flat face because some other part is going to interact with this? Well, let's go back and edit this volumetric lattice. And in order to do that, most of you would probably expect that you're going to look on our timeline at the bottom of the screen, and I should see a volumetric lattice feature. But you don't see that, do you? And the reason is because the way that this works is a little bit more of an appearance than an actual feature, so to speak. And that's part of why I was able to just go and edit the sketch and everything just updates instantly. So if I go to the body, right here under the bodies folder, and I see this solid body, I can right click on it, and this is where you're going to see the settings for your volumetric lattice. This is where I can go and edit the lattice that I've already created. And then also here you'll see where I can show or hide it. Remember I said a moment ago that this is kind of like an appearance. So if I hit the show or hide button, now it's just showing me the solid body, right? The boundaries of this boundary representational solid. If I want to turn that back on, just right click, go to volumetric lattice actions, show or hide one more time. Cool. Let's go back and edit that lattice though. So we'll go back and edit it. And now we'll go to this third tab, which says offset. Offset is going to allow you to create a shape that is solid, completely solid, or an offset from a face. So let's go and hit the plus button, and I'll choose a surface. Let's actually start with the top. It'll be easier to see. And it's automatically going to apply a 10 millimeter thickness to this. This is by default. I'm hoping that maybe in the future we change that. But right now it's a 10 millimeter thickness, and you could change that to whatever you'd like. Let's go and change that to 5. Now you'll also notice that you can change the solidity of that surface. I could also go and change that to, let's say, 50. And now it does something a little interesting here that I can see right there. I'll go and make that, let's say, 80. You'll see again those changes happening. Or I could also go and make that completely solid, and I'll go and make that 100. Now you'll also notice that there's a blend between where it goes from the super solid to the rest of that lattice. And here you're going to see that we have the ability to change the blend distance. So right now it's set to 1. I'll go and make that 5. And you'll see that it's changing the smoothing between the actual lattice and then, of course, the solid section. You could change this to whatever you'd like. By the way, when you're doing this, you can add additional faces as well. So we can go and add, let's say, the side, and now both of those faces have the same settings. If I'd like to add an additional face with different settings, I could do that too. I'll just go and hit the plus sign right here, select an additional face, and now for that face, I could have completely different settings. So I'll go and do something different for this one. We'll go make that 50, for example. Now I have a very different result. So the key here really is that you're getting some pretty wild options to be able to control your lattice and what you want out of it. Again, I'm using this cube so that it's easier to visualize what's happening, but I want to show you what this looks like on a real part. So let's go and take a look at a real part. First, I'll show you one that I've already completed. And this one on the screen is what I call a 2-point bracket. And I'll show you what this looks like in real life. So this is the part. And you can see the actual lattice structure. I have a gradient on this as well. It's a lot like less dense on this side and a lot more dense on that side. But this is a great example of trying to take a part that could be much heavier and trying to be able to lightweight this and also make this look really, really cool, I might add. And I absolutely love the results that I got with it. But I want to show you what this would look like to actually achieve. So let's go and do that. Go back to screen only. And let's go back to this file, and I'll show you what this would look like. So this is the same design without the lattice, and I'll show you what it would look like to go and create it. We'll go back to volumetric lattice, choose the part itself, choose whatever settings I want for the size of the cell, then we'll go over to the solidity. So for the size of the cell, I'm actually pretty happy with that. I'll probably leave that at 10. For solidity, I probably want something more like 25. Or maybe I actually want to go and put that gradient like we were doing earlier. Let's go and do that. Here's my lattice gradient, and I'll go and choose that particular sketch. Perfect. And then I'll go and change my settings so that I could get the gradient that I want. Again, I always change it from 0 because I don't want this to basically not exist. I want something there. So I'll go with 10 on that side, and then on this side I'll go with something like 75 this time and see what that looks like. And that's pretty awesome. But I do have areas that are critical for them to function. So I don't want a lattice, for example, inside this region right here. So let's go back to our lattice and let's go and add an offset. And I'll choose an offset for this face right here. And I could choose 10 millimeters. So now I get a nice solid face there. I'll go and do the same thing on this side. I think I might have misselected. Let's try that one more time. Yep, there we go. And for this one, I don't need 10 millimeters. That's actually a little bit much. Let's go with 5. See what that looks like. Oh, and that looks pretty good. And then what about those walls, right? Because on my part, I had solid walls. So now we'll go and add another one of these. And I could pick these faces up top. And for this, I'll probably pick something much smaller. But what you're seeing here is me picking multiple faces, one at a time. And of course, I would do this all the way around the part. And we'll go and change the thickness to something like 2 millimeters and see what that looks like. Oh, that looks great. I'm pretty happy with that. So let's pretend for a moment that I did this for the entire part and I'm happy with it. I'd go and hit OK, and then now I have my lattice structure. Now you'll notice that I use offset for all of this. So I want to show you just another way to do this that I think is really handy, right? Because the offset tool is really fast, but if you want to get a little bit more control over the solidity and you want to be able to be like really specific on what you want, then this other technique I think is really helpful. So let's go to another file. This is the same bracket, but this time when I designed it with 2 different solid bodies. So I have an area that I called lattice area and an area that I called solid design. And I want to show you what each one is. So the solid design is everything that I want to be 100% solid. So this way, I don't have to worry about creating the correct offset for this area. I don't have to worry about creating the right offset for this area or the right offset for everything else in between. Instead, I have a completely solid body that I'm not going to lattice whatsoever. I'm just going to keep it as solid. The other thing I'm going to show you here is the lattice area. And this is just the center area that I'm going to lattice. But I do want to point out that I did add 2 features in my timeline, this offset faces and then this offset face command. And what I did was I created a slight overlap between those 2 bodies. So if I highlight the lattice area, you'll see here that there's a little bit of an overlap. And I did that on purpose so that later on, when I decide to merge the 2 things together, I'm going to have enough geometry to be able to merge really well. If any of you have ever tried to combine 2 bodies that touch each other just perfectly, sometimes the combine command can be problematic. It's not all that often, but that's kind of why it happens. So in this case, I have this overlap that's going to prevent this problem from happening at all. All right, so now what do I do with this? Well, same thing like I did before. I'm going to go to Modify, Volumetric Lattice. This time I'm going to choose just the lattice area for my lattice structure. I can choose whatever settings I want. So we'll go with just some examples here. Go with, let's say, 25. And let's say for a moment, I'm very happy with this. Now I'm going to go and hit OK, and I have these 2 bodies. But a word of warning. Remember that I said earlier that the volumetric lattice is really a boundary representational solid that has additional information for what's happening inside. Unfortunately, at least today, combining these 2 together can give you some kind of weird results. So what I don't recommend is using the combine tool and choosing these 2 bodies and just saying join. Depending on which one you choose as the target and which one you choose as the quote-unquote tool, you're going to see that either everything becomes latticed or nothing becomes latticed, and that's not exactly what you were wanting. So what do you do with this if you decide to design it the way that I'm showing you here? Well, keep in mind that one of those tools that we had available was under the volumetric lattice actions, create a mesh. So you can create a mesh from the lattice structure itself, right, from that original volumetric definition of the solid body. And then you can you can tessellate the exterior solid body. And once you do, now you have 2 mesh bodies. And under the mesh tab, you'll see that we have, of course, our own mesh combine tool. So I'll show you what this looks like. I'm not actually going to run it on this because I don't want it to calculate for the next couple of minutes. So let's go over here to this file. This is the first one I showed you. And this is the end result that I ended up with. And you'll see here a single mesh body. But if you look at my timeline of what I actually did here, let's actually unsuppress this for a second and suppress this one. There we are. So what you're going to see inside this timeline is one feature to convert the actual volumetric lattice into a mesh. Then you're going to see another feature to tessellate the solid body for the outside into also a mesh. And then lastly, you're going to see a feature to combine everything together into one single mesh. Now, this unsuppressing is taking way too long, so you're not actually seeing it on the screen as I'm talking about. But I can promise you, that's actually what's in my timeline. So the next question becomes, okay, well, what can you do with this final mesh? Well, of course, 3D printing is the obvious answer, right? Like that's why most people are making lattice structures. It is very difficult to machine lattice structures, but it could potentially be possible depending on that structure. And things like traditional manufacturing processes like injection molding or casting, those could be difficult to, if not potentially impossible, depending on the lattice structure. Latticing is really optimized for 3D printing. So the mesh file that you create in Fusion 360, you can output as an STL, an OBJ, or my preference would be a 3MF file. And let's kill this screen because this is of course just watching water boil, which isn't the most fun. But you can take that mesh file type and you can of course go and 3D print it. Now, in the future development plans for Fusion 360, we're hoping to be able to just take the solid body with the volumetric definition and put it into our manufacturing workspace and be able to 3D print using our built-in slicer. That's pretty cool. That would be awesome. In the meantime, though, you can just create that STL file and use that for your slicing. And you could use Fusion 360 for the slicing, of course. You could also use an alternative. You could use whatever slicer you prefer. Right? That's perfectly fine. But the key is that right now you're going to save it as an STL. Now, sometimes people ask me, what about strength? Right? Because that volumetric lattice is lightweighting my part, but I don't know if it's strong enough. So like, what am I actually going to do about that? How am I going to go and test that? Well, we do have the ability to test solid bodies, but we don't have the ability to do virtual prototyping or FEA on mesh bodies, at least not today. So how do you actually do that? Well, let me show you what we're going to actually do. And I've got my Fusion 360 to respond. I'm going to open up a new file here. Let's go and share my screen again. Now, this particular object is, again, a 50 millimeter by 50 millimeter by 50 millimeter cube. They're really boring. But what I want to show you is how you can take that mesh and turn it into a solid body for you to actually do things like FEA. Or if you really wanted to save this as a step file or a SAT file and open it in another program that might not work with mesh files as well as Fusion 360 does, well, creating a solid body from the mesh could be really important. So keep in mind that the product design extension has more features than just this lattice ability. It also has the ability to convert meshes into solid bodies using what we call the organic method. And that's really the key here, to convert your lattice structure into a solid body. So in just a second, when this finally actually opens, I'll show you what the same 50 millimeter cube looks like as a standard solid body, as a solid body with the volumetric lattice in it, also a mesh file, and then lastly, the final solid body. All right, so here in a second, there we are. This is the solid body with the volumetric lattice as like the visual display, right? This is what we've been working with for the last however many minutes. The next thing is going to be the mesh output. So I told you that if you right click on any of the volumetric bodies, there's the option here to create a mesh. And when you do that, by the way, you'll get a bunch of different options for how much you want to refine that mesh. The more you refine it, the more accurate it is, but of course, the longer it takes to calculate and the heavier that mesh file is. But in this case, you can see that I have my mesh with all my little triangles, lots and lots and lots of them. For something like this, which by the way is still very small, let's go and take a look at our properties. And you'll see that this particular mesh has about 764,000 polygons. You can imagine that you could end up with quite a few polygons for a real part. And let's say you did want to do your FEA on it. Again, you cannot do FEA on this mesh file, but you can do FEA on this. Now you are seeing multiple faces of this solid body. These faces were created automatically based on the organic mesh conversion. So I'm not going to let it calculate, but I'll show you how it would actually work. You go to a mesh like this one, go to the mesh tab, and under convert, you're going to see the ability to choose between faceted, prismatic, and organic. The organic method is the one you're going to want for this. I will also tell you that in my experience, the base feature is the better option for something like this with a lattice structure. But I would use the base feature, organic, select my mesh, and hit OK. Now, if you are getting some failures, one of the things to note is that when you create these very organic meshes, right, these lattice structures, you really do want to check what are called shells in the mesh. So if I go to my properties here and I go to my mesh tab, you'll see that right now I only have one shell in my mesh. And if you're not familiar with what this is, shell count is not the same thing as like shelling your part. Shell count is the number of mesh bodies that are inside the actual mesh body. Kind of a weird thing, but it's a body within a body. And if you look at the original that I created when I did my conversion, you'll actually see, oh, let's go back a couple more steps. More, there we are. So this mesh body, which is what was created when I converted to mesh, if I go to my properties, you're going to see under mesh here, you're going to see that there were 8 shells. If I try to do the conversion, it is going to fail. And by the way, if you're wondering why there are bodies within bodies, so to speak, this is the great example, right? Because my lattice structure created these little small mesh elements that are really separate items, but right now it's considering it one mesh body. So what I did was I used this feature called separate, modify, separate right here, to separate this into all of the separate mesh bodies. Here you could see, I believe, 8 of them. And then I go and I convert just the one that matters, which turns out is this one, mesh body number 2. And then the rest I could just discard. I don't need them. The key though here is that the organic mesh conversion, which is also part of the product design extension, is a great way for you to be able to convert these meshes into solid bodies if you would like to or if you need. All right, so now we're on to our last topic for today. And that last topic is going to be printing in metal. So the original part I showed you, this one right here, is printed in ASA, which is very similar to ABS. I mostly print in carbon fiber, actually. So most of my prints on this Makerbot Method X Carbon behind me, I print in nylon with a carbon fiber fill, which I find to be incredibly strong. Like, I couldn't break this if I tried. I mean, maybe if I'm bending it horizontally, I might be able to break. But for its intended purposes, this isn't going to break. Now, for ASA, it's not as strong as the carbon fiber filled nylon, but it is super lightweight. Now, there are plenty of times where I need a part that's really strong, maybe even stronger than this carbon fiber part. Now, sometimes it's worth sending that part out for manufacturing. You know, there are plenty of service bureaus that'll do this for you. You know, whether we're talking about Fictive or Xometry or Protolabs or any of the other ones that are available. Keep in mind, of course, that Fusion 360 has its own cam in it. So if you have your own CNC machine, you could end up creating a part like this one made out of aluminum, right? Designed in Fusion 360, programmed in Fusion 360, and then machined using, you know, whatever machine you'd like. I believe this one was on a Haas VF3 actually. But what if you want to create or 3D print a part that is really, really strong, like that aluminum part? Well, let me show you what that would look like. This part right here, which is the same part as the one I showed you in ASA, that white part a moment ago, was printed in metal, in stainless steel, on a Makerbot Method X, just like this one right there. And that to me is just absolutely incredible. What you're not seeing from the video, which is impossible to see through webcam, is how heavy this is. Because this one is made, of course, of stainless steel. It is very heavy compared to this one, which weighs almost nothing. But this one's also significantly stronger, which I absolutely love. Now, there are plenty of metal 3D printing technologies that are out there. And I'll give you a quick overview. So let me show my screen again. Let's go to my PowerPoint. And let's get into the good stuff here. So Powderbed Fusion is really common, but really expensive. Binder jetting, very common, also really expensive. What we're talking about here today is printing on an FDM or FFF type printer like the Makerbot Method X behind me. And the picture you see is actually printing this exact part that we're talking about. And the way that it works is really interesting. It prints 80% in metal and 20% in polymer. And then you go through a process where it removes the extra material. And then you end up being left with just what you want, which of course is going to be just the metal. So the process, it goes like this. You print your part on your FFF printer. In this case, one of the benefits of the Makerbot is that it has a heated build chamber. So it prints really well with like really good tolerances and no warping. Once your part is done, you're going to end up sending it into a facility. The part, by the way, is going to be called a green part. Green is going to be basically that it's not ready yet. It is like halfway there, so to speak. So you send in your green part, and about 5 days later, you get the part back, and now it's done. So what are they doing? They're heating up that part in two different stages. The first stage is removing the polymer material, but it leaves those voids that the polymer was once there. Those voids are still there. And then it heats it up with a different process that actually fuses everything together, that like gets rid of the porosity and ends up with just a single metal part that's very, very dense. There's some shrinking, by the way, that happens in this that we'll talk about in a second, but it can give you final parts that are really, really strong. That I think is really important. So how does this work? Well, first of all, you should keep in mind that you do have to design your part just a little differently to be able to accommodate this process. So if you go to the Makerbot website, you'll find that they have an entire guide for metal 3D printing. And in that guide, it's going to give you a lot of really helpful info. But the highlights include the following 5 things. You're going to have to redesign your part just a little bit for shrinkage, part orientation, wall thickness, transitions, and then even some infill settings if you'd like. So the part actually shrinks. So basically you're going to print it 20% bigger, but in the Z direction, it's actually 26% bigger. You'll also find that when you're printing it, you're going to have overhangs. Your overhang angle requirement's a little different. Just keep that in mind as well. Also, your walls that are unsupported or too thin might end up like flopping over. That would be a big problem for you. Also, you want to make sure that like sharp edges aren't so sharp and you have fillets where you need. And even things like holes end up having perforations or keys so that you end up being able to print this better without those overhang problems. Also, you can modify your infill settings as well, so you can have weight savings too. But the key really is that by being able to use this technology, you're able to make really strong metal parts like this one. And again, like, the webcam doesn't do it justice, but this is a true metal part on par with something like this. This one made out of aluminum, this one made out of stainless steel. So keep that in mind as well. All right, so today we had a packed agenda and a 30-minute time window. I hope we were able to get to it. So our summary for today, we covered what is latticing and how it works. We covered how or where to access latticing. We talked about how to use latticing very practically, starting off from a very simple cube all the way to a real part in a bunch of different variations. And we also covered some of the little tips and tricks on how to do that right. We also covered 3D printing in metal versus 3D printing in plastic. And I just want to say that, the right tool for the right job is really important. But what I love about being able to print metal is just that you could actually just do it from home, which is awesome. Like I'm clearly not working from an office today. So keep that in mind as well. And if you do want to print in one of those first two metal technologies, of course, you could just send that out to a service bureau. They'll, of course, print it for you for a fee. And then lastly, we covered tips and tricks. And I really covered that more so in number 3, about being able to separate your bodies if you'd like to, being able to use those offsets, being able to use the sketch to modify your gradient, and how to be able to even convert the final mesh back into a solid so that you could run things like FEA, or you could save it as a step file and output that to another engineering program of your choosing. So I think that was a really great summary. And I just want to say thank you all for your time today. It's been a pleasure to have another Fusion 360 live stream with you. I love doing these. If you have any topic suggestions, please let us know. Put those in the comments, and we'd be happy to take a look at them. But thank you so much for your time today. And don't forget, with Fusion 360, you can make anything. Thank you so much. Have a good day.